Soil is a solid upper layer of the earth material. It consists of a mixture of organic and inorganic materials. It has specifically been altered physically, being broken down, and chemically broken down or changed to support plant life. Specifically, soil is classified into different particle sizes. Soil particle sizes increase in size starting with clay, silt, sand, gravel, cobble, and stone. Now there are two terms that you need to be aware of with soil is porosity. Porosity is the measure of the amount of space or pore space between the soil grains. Imagine little tiny rocks in a container. There's going to be spaces between those rocks. In the same way, if we shrink this down, that's basically what soil is. These little tiny grains, and there are spaces between them. Even though as we look at it, it seems so small, we don't think of spaces. That's actually how, when we pour water in the soil, the water seeps to the bottom because of these spaces. So porosity is the measure of the amount of space, pore space between the grains, and permeability is the measure of the ability of water. Can the water pass through? So if something is permeable, it will have the ability or it will allow water or some material to pass through it. So maybe a rock would be impermeable, would not have holes, would not have spaces, so it would not allow water to go through. The factors of soil formation include climate, organic matter, infiltration, and leaching. Climate focuses on temperature and precipitation. A climograph. A climograph actually compares temperature and precipitation. The greater the amount of rainfall, the more rapid rate of weathering and erosion can happen. Now, organic matter in the soil comes from the decomposition of plant and animal remains. Remember, organic comes from carbon and hydrogen. This is from something that used to be alive. This could be a plant or an animal. The humus is a dark, fertile, moist top layer, mainly made up of dead, decaying matter, primarily leaves that start breaking down. Maybe fungi will start breaking down these leaves, forming the organic matter. Now, infiltration, we talked about before, this is just going into something, and specifically percolation is water going into the pores and spaces of the soil. Leaching is not really a good thing. Leaching is the draining away, the dissolving of minerals. So when minerals drain away from the soil and they lack the nutrients, so this is going to be considered leaching. Now, a soil profile is a vertical section. Remember, vertical goes up and down. That depicts all of its layers. So there's multiple layers in a soil profile, and we're going to take a look at those in just a little bit. Now, soil horizon is different from a vertical profile. This is going to be more dealing with side to side, okay, each layer running parallel. So if I look at each horizontal layer, that's going to be a soil horizon. But if I look at all of them, okay, stacked on top of each other in a vertical up and down, then that would be the soil profile. Here are the 5 basic soil horizons. Now, some resources add one or omit one, but we're going to focus on the 5. O is referring to the organic horizon. Now, that's going to be just the very top one, and then as you go below that, then you have the humus, which is when you had the material starting to break down. And so this is really rich, dark soil. So remember, O, this is where the living things are. This is the very top. This could be where the grass is, leaves are on top. But then when those things start breaking down, then that actually seeps into that little layer right below. That's going to be the humus horizon, A. Below that is going to be the mineral horizon, which is horizon B. And then we're going to have horizon C and R. Now, you can create a mnemonic device, such as our aunt bakes cookies regularly. You can come up with your own, but you will need to know that order. O being on top, R, which is the parent rock, the hard rock at the bottom, is at the very base. As we said, horizon O, this is going to be where we have the living organic material. plants, maybe leaves sitting on the top, any debris, we call that leaf litter that falls from trees, maybe pine straw or other leaves. So the focus is living things are here. Then we have horizon A. The humus area is going to be also called the topsoil. Maybe you have heard of topsoil before, but this may consist of very dark, nutrient-rich soil. This may also consist of sand, silt, and clay. Then horizon B. Horizon B is called the subsoil. So you will need to know A is topsoil, B is subsoil. Sub meaning below, so this is directly below horizon A. That's why we have horizon B. Now, they have included in other resources, there's a horizon E, E as in elephant, between horizon A and B. We're not going to focus on horizon E, but different resources have plugged in a horizon E between A and B. Now, horizon B is usually going to be focusing on any materials that seeped from horizon A. It's seeping down into horizon B. And remember, we call that leaching if it's seeping away or draining down. So some of the nutrients, which are going from this really strong nutrient soil in A, will seep down to B. Then we have horizon C, okay, which is called the saprolite. This horizon is the least weathered horizon. So it's not going to be broken down. It's going to contain loose parent material, and it may have some material coming down from A and B. And then the very last one here is horizon R. This is the bedrock. This is the strong parent material. Remember, if it starts loosening up, that's going to be right above it. That's going to be horizon C. But primarily horizon R is a strong, hard rock material. Here's a good illustration to illustrate that. You have the organic material on O. You have the humus, which is horizon A. And as some of that seeps down to B, okay, you have the subsoil. So A is topsoil, B is subsoil. And then you have horizon C, which is going to be the loose parent material. You can see some type of rocks there, but it's more loose. And then you have R, which is the bedrock. Now, there are a couple terms here that you do need to be aware of. The regolith is primarily illustrated as all the weather material within a profile. Basically, it has two parts. It has the solemn and the saprolite, and we talked about the saprolite in horizon C. So the solemn, this is going to be the upper horizons, and then the saprolite are going to be the lower horizons, okay, the least weathered portions. Now, there are many different ecosystems, many different locations that have different soil profiles, different terrestrial soils, depending on the minerals that we learn. If it's going to have a dark red, maybe desert soil. If it's red, it's going to have a lot of iron in it. I know here in North Carolina, we also have a lot of red soil, okay, identifying that red comes from the oxidation and the reaction of oxygen and moisture reacting with iron, specifically hematite. Now, scientists will primarily use the Munsell system of color notation, and this is a color catalog which helps them identify the mineral and the material makeup of the soil. And this is going to show hue or specific color. This is also going to show value, which is lightness or darkness of the color. And then chroma, which is light intensity. Let me show you a picture. Here is hue. Okay, different colors. We said if there's a lot of iron, it's going to be more red. If it's other colors, it may have other minerals in it. If it's more of a greenish blue, it may have more copper in it. Here's the value spectrum. If it's going to be light to dark, and remember, if it's going to be more light or lighter color, it's probably going to have more leaching. A lot of the minerals may be taken away. If it's going to be dark, perhaps, okay, richer, stronger, nutrient-rich soil. And here's our chroma intensity, also showing an intensity of the color versus, and as we said, some of the soil colors may be impacted by the different minerals, or if there's many carbonates, salts, or if it's leaching, if there's high organic material. Okay, so we did talk about hematite, iron giving red. There's some other minerals here that we did not talk about that may yield a yellow color or a brown color or even a purple color.